So I'm going to go over the worksheet. It's not crazy, bro. All right, so first part is a series circuit. Again, how do we know it's series? Just trace that pathway. All right, one pathway, single series. So to find the resistance total, we just add them up, R1 plus R2 plus R3, which in this case is 1 plus 2 plus 3, 6 ohms. Question 2, find the current across the battery. Well, we know everything has the same current, so we can just use V equals IR. We know the resistance is now 6, and V is 24, so we get a current of 4 amps. Question 3, okay, which resistor has the most current running through it? The answer is they all have the same current. There is only one pathway for this to travel through. Think of current as water moving, okay? Like a lazy river. You're all these resistors are different people, okay? So even though they have different values like skinny person, middleweight person, fat guy, whatever, since it's one pathway for the lazy river, they all have the same movement. They all travel in the same flow. They all have the same value for current. Okay. 4. Okay. So to find how much voltage is applied across each resistor, because it's a series circuit, we know that all 3 resistors have the same current. In fact, how much current do they all have running through them? We found it 4 amps. That was the answer to number 2. So if we know each resistor has 4 amps of current running through it, and we know the individual resistor values, 1 ohm, 2 ohm, and 3 ohms respectively, to find voltage, we just multiply the current 4 by each respective resistor value. So we get 4 volts, 8 volts, and 12 volts. And if we add them all together, 4 plus 8 plus 12 is 24, which happens to be the exact same voltage as the battery. It's a way you can check your work to see if everything makes sense. And in a series circuit, the voltage of each resistor should add up to the total voltage of the battery. So that is the series circuit. All right, for the parallel portion, all right, the first part is, first off, how do we know it's parallel? We trace with our finger, and then as soon as we realize we can take more than one path, we have multiple choices, it's not series, it's parallel. And when they're drawn out schematically, sometimes they look like parallel to each other, like parallel lines, parallel. Okay, so to find the current in each branch, since it's a parallel circuit, every branch has the same voltage applied to it. So every branch gets the full 24 volts. However, since there's multiple pathways to travel, the current can differ in each branch. So in this case, to find the current in each branch, we take the voltage overall, which is 24, and divide it by each respective resistor, and we get 24, 12, and 8 amps respectively through the 1, 2, and 3 ohm resistor. All right, 11. This is the hardest part of all circuit problems, is just finding R total when you're talking about basic series and basic parallel problems. So to find the parallel resistance total, you cannot add them together. You must add them as reciprocals, 1 over their respective values. So 1 over R total is 1 over the first resistor, which is 1, plus 1 over the second resistor, which is 2, plus 1 over the third resistor, which is 3. When you add them together, you cannot make this 1 plus 2 plus 3 and make this 1 over 6. That's not how you add fractions together. So you can just find the least common denominator, which happens to be 6, and when we add them together, we get 11 over 6. All right, which is the same thing as 1.83. That is 1 over R, so we have to flip it to find R. So R is 6 over 11, or 1 over 1.83, which is 0.545. Right. So that's the resistance of the entire circuit. It's the 0.545 ohms. Right. Well, if we know that, to find out the current across the battery, we use V equals IR. We know the voltage is 24. We found the resistance to be 0.545. And when you solve, you get basically 44 amps. And if you add the 3 currents from each branch, 24 plus 12 plus 8, you also get 44 amps. So in a parallel problem, the current of each branch should add up to the current across the battery. And in a series problem, the voltage across each resistor should add up to the total voltage of the battery. And last but not least, number 14, which resistor receives the greatest amount of voltage? And the answer is, again, we already answered this, they all get the same value for voltage. All right, so this is the video review of the key. If you have any questions that I didn't explain enough, don't hesitate to shoot me a remind. Have a great weekend, and I'll talk to you guys later. Bye.